Exercise 2.4 part 1. We are going to see exercise 2.4 in two parts. Okay. First we'll see the part 1. First we see the quadratic equation. What is quadratic equation? You learned what is quadratic equation in lower class. So quadratic equation will be in the form of ax square plus bx plus c is equal to 0. When you take a outside in common, the equation will be like this, that is a into x square plus b by a into x plus c by a, which is equal to 0. Now take this a and bring it to the right hand side. So 0 by a is equal to 0. Keep this as equation 1. Okay, this is the form of quadratic equation. Suppose if the roots of the equation, you know that a quadratic equation will have two roots, isn't it? So let us consider the equation, let us consider the roots as alpha, comma, beta. Right, if the two roots are given, so you can easily frame the quadratic equation in this form, that is x square is x square minus sum of the roots, that is alpha plus beta into x plus alpha into beta, that is x square minus sum of the roots into x plus product of the roots, which is equal to 0. So when comparing the equation 1 and the equation 2, we can say that sum of the roots, that alpha plus beta is nothing but minus b by a, and the product of the roots, which is alpha into beta, which is equal to c by a. So these things are already you learned in lower classes. Now coming to the quadratic polynomial. Quadratic equation and quadratic polynomial are almost the same. The thing is, equation means it is equal to 0. That's all. So same way, if I take a outside from this polynomial, so it becomes a into x square plus b by ax into c by a. Now consider the same way, alpha and beta be the zeros of the polynomial. See, you must know the difference between the roots of the equation and zeros of the polynomial. Roots of the equation means what? The alpha value and the beta value are the roots. That means that will make this equation to be satisfied. Can you understand? When you substitute alpha in the place of x, this equation will be satisfied. When you substitute beta in the equation, this equation will be satisfied. Here in the polynomial, when you substitute alpha in the polynomial, this polynomial becomes 0. That means the value of the polynomial is equal to 0. So the polynomial becomes 0. So 0 of the polynomial. That is why we say here it is 0 of the polynomial, not the roots of the polynomial or equation. Okay, right. So here I have taken the a outside, but I cannot eliminate or cancel the a. Just compare here. Here it is c x square minus alpha plus beta x plus alpha beta is equal to 0. But here the a remains. So that is the only difference. So whenever you are asked to find a quadratic equation, you can take like equation 2, and whenever you are asked to frame a quadratic polynomial, you must take like this. That means this quadratic equation must be prefixed by a. Now we'll get into the problem. Construct a quadratic equation with roots 7 and minus 3. So let us take alpha and beta be the roots of the equation. So what alpha is equal to 7 and beta is equal to minus 3. Now you have to find the sum of the roots and the product of the roots. So alpha plus beta is the sum, so which is 7 minus 3, which is equal to 4, and alpha into beta, which is the product, so which is equal to 7 into minus 3. 7 into minus 3 is equal to minus 21. You know the equation of the quadratic, quadratic equation, isn't it? X square minus alpha plus beta into x plus alpha beta, which is equal to 0. So x square minus, just replace alpha plus beta with that value, which is 4. So minus 4x. And the same way, alpha into beta value, which is minus 21, you can replace here. So finally, the equation is framed, that is x square minus 4x minus 21, which is equal to 0. Sum number 2. A quadratic polynomial has one of its 0, 1 plus root 5, and it satisfies p of 1 is equal to 2. Find the quadratic polynomial. Keep in mind, you are asked to find the quadratic polynomial, right? Now 1 plus root 5 is the 0 of the polynomial. It is given in the question itself. So you know a theorem that conjugate roots occurs in pair. We learned in lower class. That means if 1 plus root 5 is a root or 0 of the polynomial, 1 minus root 5 is also the 0 of the polynomial. Can you understand? Just take the conjugate of the root. If you have a radical root, can you understand? So 1 plus root 5 is there. So conjugate of 1 plus root 5 is what? 1 minus root 5. So this is a root. So this is also a root or 0 of the polynomial. So consider this as alpha and consider this as beta. Okay, so alpha and beta be the zeros of the polynomial. So alpha is equal to 1 plus root 5, beta is equal to 1 minus root 5. Now we have to find the sum and the product. So alpha plus beta is 1 plus root 5 plus 1 minus root 5. So root 5 and minus root 5 cancel. So 1 plus 1 is equal to 2. Now product of the polynomial. So alpha into beta, which is equal to 1 plus root 5 into 1 minus root 5. Just look at this factors. It looks like a plus b into a minus b formula. So you know that, which is a square minus b square. What is a? 1. So 1 square is 1 minus what is b? Root 5. So root 5 the whole square is what? 5. So 1 minus 5, which is equal to minus 4. Now we have to frame the quadratic polynomial. So quadratic polynomial, let us take as p of x. Okay. So quadratic polynomial will be in this way. Previously I taught you that it is a into x square minus sum of root x plus product of the root. Okay. So that is equal to a, we don't know, sum of the zeros, that is alpha plus beta is 2, so it is minus 2x, and alpha beta is minus 4, so it is minus 4. Now it is time to find the value of a. And how to find the value? A condition is given in the question that p of 1 is equal to 2. So what is p of 1 is equal to 2? When you substitute 1 in the polynomial. What is the polynomial? This is the polynomial. In this polynomial, if you substitute 1, that is in the place of x, you will get the answer is equal to 2. So take this polynomial and replace all x value by 2. So here you have to substitute 2, and here also you have, here you have to substitute 1, here also you have to substitute 1. So I have substituted and I have written in the left hand side, which is equal to 2. So a into 1 square is 1, minus 2 into 1 is minus 2, and minus 4, which is equal to 2. So 1 minus 2 minus 4 is minus 5. There is a, so which is minus 5 into a, which is equal to 2. So bring this 5 to the denominator. So a is equal to minus 5 by 2. Now you got the value of a. Substitute in the quadratic polynomial in the place of a. So finally the required quadratic polynomial is what? Minus 5 by 2 into x square minus 2x minus 4. Next problem. If one of the roots, that means one root is given, k into x minus 1 the whole square, which is equal to 5x minus 7, is double the other. Show that the value of k is equal to 2 or minus 25. So it is given one root is double the other. What do you mean by double? Suppose the root is 2 means other root will be 4. That means 2 into 2, 4. Suppose the root is 5 means the other root will be what? 10. That means just double it, add, just multiply by 2, or you just add the same value to it. So I have taken the first root as alpha. So doubling means what? 2 into alpha. Here it is not beta, 2 alpha, because the condition is given in the question. Take a root and double to find the other root. So 2 is one root and 2 alpha be the other roots of the equation. Now the given question is written here. Now you have to just expand it and you have to form a quadratic equation first of all. So that I have taken this k and multiplying inside this bracket value. So k into x square plus k into 1 is k minus 2x into k is minus 2kx. And also 5x minus 7 is in the right hand side, bring that to the left hand side. So 5x becomes minus 5x, minus 7 becomes plus 7, which is equal to 0. Now you just group together just for your own identification to see that it's a quadratic equation. So there is an x square term, so I have written kx square. See, there is 2x term, minus 2kx and minus 5x. So I have grouped the two terms, and I have taken minus x outside. See, a minus is taken outside, x is also taken outside. So inside I have 2k plus 5. Now 7 and k is remain. So 7 plus k is bracketed because that is the constant term. So this looks like a what? A quadratic equation. Now you know that coefficient of x square is considered as a. So a is what? K. And coefficient of x is considered as b. So b is equal to minus 2k plus 5. And c is the constant term, which is 7 plus k. Now we are going to follow the same procedure, sum of the roots and product of the roots. Sum of the roots means what? 2 plus 2 alpha, which is equal to what? Minus b by a, isn't it? I taught you in the beginning, the first slide. So minus b by a. What is b? This is b and this is a. So minus of minus 2k plus 5 means it is 2k plus 5 divided by k. So alpha plus 2 alpha is what? 3 alpha, which is equal to 2k plus 5 divided by k. Now bring this 3 to the denominator. So alpha is equal to 2k plus 5 divided by 3k. Consider this as equation 1. Now product of the roots. 2 alpha into 2 alpha, which is what? C by a. What is c? 7 plus k. So 7 plus k divided by k. So alpha into alpha is alpha square. So 2 alpha square, which is equal to 7 plus k divided by k. Now bring this 2 to the denominator. So alpha square is equal to 7 plus k divided by 2k. Now you have to eliminate alpha. To eliminate alpha, I am going to substitute this alpha value, which is 2k plus 5 divided by 3k in the second equation. It means substitute 1 in 2. So in the place of alpha, that is in the second equation, I am going to replace 2k plus 5 divided by k. So there is a square, so I put the square here. Now I have to make the square term for the numerator and also for the denominator. So if you have the square for the numerator, it looks like an a plus b the whole square formula. What is a square? 2k the whole square, so 4k square. What is b square? 5 square. 5 square means plus 25. Then you have to multiply 2 into a into b. So 2 into 2k into 5, which is plus 20k. Denominator 3k the whole square, so 9k square. Now you have to cancel the k term in the denominator. The square term and the k is cancelled. So it is 9k in the denominator of the left hand side and in 2 in the denominator of the right hand side. Now cross multiply. Multiply the numerator of the left hand side by 2. So it becomes what? 8k square. 25 into 2 is 50. 20k into 2 is 40k. And right hand side numerator by 9k. So 7 into 9k is 63k. And 9k into k is 9k square. Now bring all the terms to one side. So I am going to bring the left hand side, left hand side term to the right hand side. So 8k square goes to the right hand side as minus, and 50 and 40 also goes to the right hand side as minus. So that is written here. Now you have to simplify. Minus 8k square plus 9k square is k square. Now minus 40k plus 63k is 23k, and minus 50, which is equal to 0. This is the quadratic equation, and you know how to solve the quadratic equation in the tree method. So minus 50 can be written as 25 and minus 2 divided by k and divided by k. So k plus 25 into k minus 25, which is equal to 0. So k is equal to 2 or k is equal to minus 25. So that is what we have to prove from the question. So hence it is done. Sum number 5. If the difference of one of the roots, if the difference of the roots of the equation is equal to, it is given, is equal to the product, prove that a is equal to 2. Okay, so we have to take two roots. The difference of the roots is equal to product of the roots. Okay, I'll explain that. I have taken alpha and beta be the roots of the equation. Now you consider this equation. This looks like a quadratic equation. What is the coefficient of x square? Which is 2. So this is what? A. What is the coefficient of x? Minus a plus b. So this is b term. What is the constant term? A minus b. So this is c. Now sum of the roots, alpha plus beta. What is alpha plus beta? Minus b by a, isn't it? So this term is taken and it is written here. Okay, so it is a plus 1 divided by 2, which is written here. Then alpha into beta term. So alpha into beta is what? A minus 1. So a minus 1 by 2 is written here. Right? Now you see here alpha minus beta is equal to alpha into beta. It is given in the question itself. Okay, it is given in the question. See here, difference of the roots is equal to the product of the roots. What is the difference of the root? Alpha minus beta. What is the product of the root? Alpha into beta. So now I am going to square on both sides. So it is alpha minus beta the whole square is equal to alpha into beta the whole square. Right. Now alpha plus beta the whole square, you know that alpha minus beta the whole square can be written as alpha plus beta the whole square minus 4 alpha beta. You learned in 10th standard in algebra chapter mathematics. So using that, this formula has been written. You know the value of alpha plus beta, which is a plus 1 by 2. It's not minus a plus 1 by 2. It is wrongly written a plus 1 by 2. So a plus 1 by 2 the whole square minus 4 into alpha beta. What is alpha beta? A minus 1 by 2. So a minus 1 by 2 is written. Right hand side also a minus 1 by 2 the whole square. So a plus 1 the whole square means a, just like a plus b the whole square formula. So it is a square plus 1 square plus 2 into a into 1, which is 2a, divided by 2 square. 2 into 2 is what? 4. Minus, here in this term I want to have the common denominator. So I am multiplying the numerator by 2 and denominator by 2. So 4 into 2 is 8. 2 into 2 is 4. Right hand side also I am going to explain using a minus b the whole square formula. So a square plus 1 square is 1 minus 2 into a into 1 is minus 2a divided by 4. The next step, I have cancelled all the 4, that is divide the equation, multiply the equation by 4, so all the denominator terms are eliminated. Now remaining terms are written. So when you bring this minus 8 inside, it becomes minus 8 into a is minus 8a, minus 8 into minus 1 is plus 8. And remaining terms are written as it is. Now see here, a square and a square are cancelled, 1 and 1 are also cancelled. Now 8a minus 8a plus 2a is what? Minus 6a, and there is a minus 2a on the right hand side. Bring it to the left hand side, it becomes plus 2a, and there is a 8 in the left hand side. Bring it to the right hand side, it becomes minus 8. So minus 6a plus 2a is equal to minus 4a, which is equal to minus 8. Cancel the negative, so that is minus. Bring the 4 to the denominator, a is equal to 2. So that's all about today's class.